So good evening, everyone. As you all know, it's 21 days data science tools FDP, international FDP, and today we are going to see about a NumPy. So a NumPy is a structure which is efficient for the numerical computation. So we'll start. Let me give how the next 1.5 hours is going to be like. I'll just give the overview of the NumPy package. Then we will see some of the what are the built-in functions that are available in the NumPy packages, and what is the difference between that existing data, that is whatever the data structures or collections available in the Python, and also what is how NumPy is different from the other available data structure that are provided by the Python programming languages. Some of the examples as hands-on examples. So first and foremost thing I just want to clarify, just tell me like the brief, like just an introduction about the NumPy programming packages. So NumPy stands for Numerical Python, and it is a fundamental package for high performance computing and data analysis. So as you all know, whenever we are using a data analysis or whenever you are using any experiment or any investigation or any data exploration task, we need to deal with matrices and vectors, all those things. So for that, the first and foremost fundamental package we need is NumPy. And also it is so very important for the numerical computation. As the name itself suggests, it's a numerical Python. So that with the help of these packages, we can do many statistical analysis, and also we can do many numerical computations in the Python programming languages. So what you will find exactly in NumPy? So we are having many packages, right, from like pandas, NumPy, all those things. And what you will find in this particular package, that is NumPy, is the first and foremost thing is ND array. So ND array is like an efficient multidimensional array, which is provided for arithmetic operations and also broadcasting capabilities. So we will see what is a broadcasting capability in detail in a few minutes. Okay. So ND array is a feature which is provided. It's like it's a multi-dimensional, it's a higher dimensional array. With this, I can easily perform any arithmetic operations. Not only on the vectors, I can easily do arithmetic operations in a multi-dimensional arrays. And also, it's a mathematical. It provides many mathematical functions that can fasten the process. If we are using without writing any loops, that is without performing the element by element operation, element wise operation, we can directly go for the fastening the operation by using this NumPy packages. So it is a tools, it provides a tool for reading or writing a data to a disk and working with the memory mapped files. And also it is very much efficient for linear algebra, random number generation, and Fourier transform capabilities. So if you are using any data analytic tools, you need linear algebras, basics and all, and also random number generation is right not only for the data exploration, also for the security purpose. All those things we need the PRMG, random number generations and all. And also in NumPy, you can have an API, application programming interface, for connecting the NumPy with the libraries that are written in C or C++, that is different programming languages. So this gives the choice for wrapping the legacy of code bases. So these are the things you will find in a NumPy that can be these are the features that makes the NumPy to be a more important one when compared to the existing already available packages and all. So as you all know that the NumPy is a package, and the very first point, it provides a ND array. So what is meant by ND array? ND array is a data structure. So NumPy adds a new data structure to the Python that is called NDArray, which is an n-dimensional homogeneous collection of items. So with the help of NDArray, obviously array means a collection of elements or collection of items. So here we are going for an n-dimensional array. That is what ND. ND refers to n-dimensional. That is more than two-dimensional. Okay, we'll see what is a single dimension and then what is meant by two-dimensional in a couple of slides. So NumPy adds a new data structure in Python, and also an n-dimensional array is a homogeneous collection of items indexed using n integers. It can be defined, which the ND array can be defined by using the shape of the array and also what kind of item that the array is composed of, whether it is a string that particular array is composed of. So these two features are required for defining an ND array. So first, let us explain. So let us first see what is the difference between how we are going to use this. What is, because we are having many notations. So apart from all the notation, we are going to see NumPy and that too NDArray. So before we are going to exactly to the NumPy and NDArray, we first look at what is maybe vectors and matrices and arrays using NumPy. So let's start by collecting some object together, which means I just want to store the objects together. Okay, so what are the different collections or what are the different data structures available in order to store the objects together? First, we will start. So if I want to store a single object, okay, so say for example, I want to store only one element. Okay, so such type of data structure, such type of object is called scalar object. If I'm storing only a singular, okay, if I'm storing only one object, that is called scalar. Or else the next option is if I want to store the collection of scalar. Okay, not only a one element, I just want to store the collection of scalars either in a two-way, either in a single row or as a single column, or we can simply call it as a list. So if I want to store the collection of elements, obviously list is the collection of elements. So if I want to store a collection of scalar objects, then that is going to be called as a vector. Then what is meant by matrix? So collection of vector, that is list of list. Okay, so if I store single row or single column, that is going to be a vector. If I store both row and that is list of list, okay, so that is going to be called as a matrix. So that is collection of vector is going to be called as a matrix. So single object is going to be called as a scalar, and if I want to store a collection of scalar in a single row, that is number of scalar elements together, that collection is going to be represented as a vector. And if I want to collect the vector together, and that is going to be represented as a matrix. Then what about NR? So if you're going for higher dimension, say for example, in the matrix we are having 2D, that is two dimension. One is row, another one is column. If I want to store, because whenever you're going for a data exploration or data analysis, we need to deal with the higher dimensional higher dimensional in data sets and also. If I want to go for a higher dimensional and all, then we can call it as a array. So we have one example. So here I'm just showcasing only the figure. Okay, so if it is a single element scalar, collection of scalar is going to be called as a vector, collection of vector matrix. If I want to deal with the n-dimensional objects, not only a two-dimensional, that is apart from row and column, I want to store one more dimension of element, that is going to be called as a array. So in this example, say for example, I am having a experiments, time and sensor. So here I just want to conduct, say for example, in my laboratory, I want to conduct experiments for several times. Investigation. That is, I want to do some experimental analysis. So I'm just conducting experiments for several times. That is a repetition. So say for example, I'm conducting experiments n times. And also the experiment is all about each and every experiment. That is, each experiment is going to be collect the data from the sensor. So that is what my experiment is going to be. So I just first define the experiments. I just want to carry out the experiment for n times. And for each time, for each experiment, I want to collect the data from the sensor. Say for example, I'm having a temperature sensor, pressure, and I'm having a temperature, pressure, all the sensors are there. So if I want to collect the data from these sensors, so I'm having K sensors, and I have the sensors from all the sensors, that is each and every experiment, I want to collect the data from the sensors. Each and every time I want to collect the data from the sensors. And also apart from these two, if I want to go for collecting the data on a regular interval basis, say for example, I want to collect the data on a regular interval like 5 seconds. 5 seconds. So which means like I want to do the experiments, and this experiment is each experiment have to collect the sensor data regular interval of basis of j, that is 3 seconds or 5 seconds or 4 seconds. So this is going to be a multi-dimensional. So earlier we have with like 4 for time or sensor. So now I want to, when you are going for a higher end application, I want to deal with the high dimensional data. That's a more data. So that is we are just explored here. So experiment, sensors, and time. So I want to carry, in that case, I need a multi-dimensional space or multi-dimensional object to store all the data. So for that, I can use the ND arrays and all. So we can do all the statistical analysis apart taking the, so I want to have a relation between all the three axes. So Z representing experiments, J and K. So I want to do the analysis, or I want to make a relation. What is, how this data is varying. So what is the relation, hidden relation behind this in this particular result. So in that case, I want to record all the data and store it in somewhere. For that, I need a n-dimensional object, and that is going to be a ND array also. So this is just an example that we can showcase for a scalar data when we are going for a n-dimensional arrays. So we have seen what is ND array and all. Is it same as list? Because we have already seen what is vector and what is list and all. So what is the difference between ND array and list? So we can, you may ask yourself, like, I'm having a list. As you all know, list is a collection of elements, obviously. And also the main advantage of list is you can collect like both similar or dissimilar items also. Okay, so if I'm having such advantage of the rest advantages in a list, why can't I use the list for making the numerical calculation by simply using a for loop? So why I need to go for an umpire? What manner it is different from the list? Okay, so that is what the basic questions whenever we are studying our list in this manner. So there is like basics of Python and then loops, all those things. Then we are going for a list, dictionary, all the data structures, and then we are going for a packages import, that is data constructs and all. We'll have, so already I have seen the list. With the list, I can store a color elements both in similar or dissimilar. So if I want to process or if I want to do any manipulation, I can simply use list comprehension, or I can use some for loops and all. So what do I need to go for NumPy array, or why is it exactly needed? So there are significant advantages of using this NumPy array. So we'll see what is the advantages by looking at the example. There is some like some of the points. Okay, so creating a NumPy array. In order to understand the advantages of the NumPy array, first we have to let us create an array, and then we can see what is the first advantages when compared to the list. So one of the most, as you all know, there are many built-in functions. As this NumPy is a package, so package is just whenever you're going for any trucking on runner, we have to carry a baggage. So baggage in the sense what? Putting all the stuff and just pack it and then go for wherever you want. Similarly, here also package means we have all some of the built-in functions with respect to numerical. So all the built-in functions with respect to numerical computations are put into a one package, and you can use it as a under NumPy. Okay, so that is the, just you can correlate the NumPy along with your as a package, Python package with the luggage also. So in a luggage we have all the stuffs. So similarly in packages also inside we have like many built-in functions. So to understand these advantages, first we'll create one array. So first I'm using a NumPy array, creating a NumPy array by using array function. So this is first built-in function. So how can we create an array? So simply first and foremost thing, we have to import the particular package. So you can simply use import NumPy, or you can use import NumPy as NP. If you want to give the alias name, you can use as NP also. So I'm giving a list. So here what I'm going to do now, I'm just passing a list as an argument. So I'm just taking a list as an argument and creating an NP array, that is NumPy array. So I'm creating a list that is of elements of 5, and I'm passing the particular list as an argument for the NP array. So if I want to find out the type and the array, so it's a very basic. So if I want to find out the type of the array and type of that particular, that is print the array, you will get that is numpy.nd array. So this is the main type, that is a data type of the particular array, that is you can note as a ND array. And this is the array which has been created by passing a list as an argument. Okay, first point is done. We have created the NumPy. And what is the advantages of NumPy? Still we are, the particular question is still left out. So what is the advantages? So, and before going to the advantages, first the main key pointers, like it should be noted that once you created an NumPy array, you can't increase the size, and if you want to increase the size, you have to create a new array. So this points to be noted. This is a key point. You can take it out from the creating array. So this is the like example of how to create an array, NumPy array using array function, built-in function. And then what is the, how it can be differed now? So the main difference is that arrays are designed to handle vectorized operation, while a Python list owner, which means I can use the vector based operation. Okay, so I can use, like, instead of going for each and every object, that is what we have seen already. So vectorized means what? A vector means what? A collection of scalar, that is collection of elements. So I can perform the operation in a faster manner because we are doing a vectorized operation. Not we are going for an element by element. We are just going like we're just doing every item in the array rather than the whole array object. So this is how that is the main difference between the list and the ND array. So here I have taken one example to showcase how this can be done. So if I want to add the number 2 for every item in the list, so what you will do, so say for we are currently dealing with how the list is different or how the ND array or NumPy is different from this list. So if I want to do the manipulation, as we all know, list and NumPy is both to be a collection of elements. So if I want to do some manipulation in this collection of elements, so say for example, I want to add the number 2. Okay. So first I can write the code like input NumPy. Okay. And then I'm giving a list. Okay. 0, 1, 2, 3, 4. And then I'm just adding an element. That is, as per the problem statement, I want to add the number 2 on every element so that the output can be like 0 plus 2, 1 plus 2, 2 plus 2, 3 plus 2, and 4 plus 2. But if you carry out this operation, list plus 2, it gives the error. Okay, the type, it is going to be called as type error because the list can only concatenate the list because the plus represent the list concatenation. So we can't use this operation. So it's representing a concatenation. So what we can do now in us, that was not possible with the list, but you can do it on the array. So how you can do it now? First, make it as an array, and then you can do array plus 2 so that I can take all the elements because list is considering everything as a single object. So, but here I'm taking like 0, 1, 2, 3, 4, and then I'm just adding an element 2, and that can be possible in the 2, 3, 4, 5, 6. So instead of writing a for loop or instead of writing an element, I can directly take as a single object and I can do the operation. So this is the major advantage when compared to advantage of NumPy when compared to the list. So just with this notation, we can go for like so to witness. So how we can just use the NumPy array by using some hands-on. Okay, so because like as you all know, as a package we are having like a lot of built-in function. So before going into like instead of taking the outing, so we can just go to hands like using some like code, and then we can explain like, and then we can just discuss what all the code is refers to. So I'm just sharing my I just use the Colab only. So yeah, so I hope this screen is visible right now. So, as you all know, like you can use any IDE, you can use like Anaconda, Jupyter Notebook, or you can use a Python command prompt also. So I just used Google Colab because like comparatively we can use Google Colab also. So I access the drive, so we can access anywhere we want. So instead of carrying all those stuff with us, so I'm just explain some of the, so with the basic introduction in the given in the PPT, I'm just going for the like hands-on. So if you like, you can simultaneously you can execute the code also. I can wait for because I have only like a simple code snippet. We can have only simple snippets, so you can just visualize and then you can just execute simultaneously also. So as you all know, NumPy arrays, I'm just giving an intro like a structure of efficient. So first and foremost thing is environment setup. So how to set up the environment? Yeah, so environment setup is just we want to import the packages, and if you are using some, as I'm using this in a Google Colab, I don't need to install the particular package. But if you are using your system, so in your local server, if you are using any local server, you have to obviously install the particular package so that you can use. If you are using Conda, you can use Conda install that particular command, or else you can use pip install also. So pip install NumPy is for installing a NumPy package. As I'm using a Google Colapse, I don't need to install the package. But if you are anyone is doing a local server, so you have to obviously install the package. So the package command is pip install NumPy. So once you install the NumPy package, you can directly import the particular package. And also, this is just an environmental setup to check what version that the current NumPy I'm using for. So I'm just given like import NumPy as NP. As you all know, like is it optional? Even if you want, you can use this aliasing, or you can simply use import NumPy. But why we are using this antenna just for again for like a convenience only. Okay, so if you're not giving now, you can use numpy dot version, numpy dot array, numpy dot ndarray. Everywhere we have to use the same. So I'm just using as np. So we are having print, and then I'm just want to see the version of the this numpy package. So the version is 1.22, that is 22.4. So first we will see how to create the arrays. Okay, so I'm just creating an array using range function. So already we have seen one function that is called like the NP array.
Ma'am, are you now presenting your workflow?
I'm just presenting a NumPy or the Google Colab.
We can't see it, ma'am. We can only see your PPT.
Oh, okay, sorry. I forgot to share the particular. Wait, just give me a second. And I just thought of about a different platform. Oh yeah, we have to give the separate screen too, right? Thank you. I hope now you are seeing my this particular. I thought it's an entire screen, sharing entire screen. Sorry, ma'am, is this visible now?
Yes, ma'am.
Yeah, thank you. Sorry, I thought like it's like a sharing an entire screen, but it's a WebEx, so we have to share the screen separately. Sorry. So first I have used this environmental setup, that is import numpy as np, and then I just given that environmental setup to check to first importing the package as well as I'm checking the version. So I already I shared this notebook also. Like later on once the session is over, I'll share that notebook. So how to create an array? So earlier we have seen passing a list as an argument. Here I have taken a different, that is I have considered two also. As first one is I'm just giving a list, and also I'm using a range function. So this is first one is just we already what we have seen earlier, no, earlier time. That is creating a list and then passing a list as an argument. So I'm just giving a 1, 2, 3, 4, 5, and then printing an array. And the second one, A2 is also a numpy array, but I'm using a range function. I hope you already are familiar with the range function, but anyway. So range function is just we are creating there is a proper syntax for the range function also. We have a start and then in between we have a increment also. So like incrementing of, if you are not mentioning a increment and all, no, so it will by default increment by one, or else if you are mentioning about increment, it goes as per the what you have mentioned or as per the argument. So here I'm just simply giving the n. So range of n, which means it starts by default, it starts from 0 and goes till n minus 1 till n 1. That is, here I didn't mention any increment, therefore I'm just going for a just unit wise implementation. So that is, so we have created the array that is 1, 2, 3, 4, 5, and then we have just creating using a range function also. So this is like, yeah. So we have created using a range function that is from 0 to n minus 1, and also by using passing a array. And some of the, this is a very basic one, or you can create an array using different functions also. Say for example, ones, zeros, all those things. Some of the commonly used numpy functions are like a square root, ones, zeros, and copy functions and all. So as it's like a vast, like numpy itself a package where we are having a number of built-in functions. We'll see. I'll try to cover at max. So numpy square root, ones, zeros, and copies. So here I'm just having a, yeah. So creating an array of zeros in a given shape. So I just want to create an array of zeros, which can be used for like an image processing application and all. If I want to go for like, or else if I want to give some C or like any other matrix full of zeros for like a further computational, I can create this np.zeros. That is, I can use this np.zeros function to create a matrix full of zeros. So here I'm just giving a shape also by specifically giving a shape 2 comma 3. Okay, so 2 comma 3 in the sense like I'm giving, I just want to create the np array, that is we have using a two dimensional. So if you're using just giving a list alone, it create a list as an array, or you can give a range of function n. If you're using if I'm mentioning like n comma n, that is n comma m, no? So which means like n rows and m columns. So I'm giving 2 rows and 3 columns. So this is like zeros and all. So next one is like we can have also create an array of ones. So with the same shape and data type as a given array. So just by each and like one by one example, we can see some built-in functions. Okay. So here, create an array. If I just want to create an array, but without mentioning the shape, but I want to use the existing, that is the array which I created a zero array. Zero array shape is 2 by 3. So I just want to use the shape, like I want to create an array of ones with the same shape as zeros. That is the array of zeros. So for that, we have to use like function. So that is np.ones underscore like, that is representing a just create an array with a same shape whatever argument you are passing. So if I'm passing zeros means that is gives a like the shape of the zero array. So here, like, I'm not passing any shape, so I'm just giving the array only. So existing one, the existing one is 0 array, whose shape is 2 cross 3. So I just want the array of ones to also look like have a shape of 2 cross 3. So I'm just passing this one, and we'll have like one column is 2 rows and 3 columns of one. So next one is like, so these are like, so for example, we are, apart from this, we are having like ND array, all those things functions array. So there are like a lot of functions for creating array itself. So I just cover up some of the basics and like most important functions on that. Then we can go for the next built-in functions. Not only for the creation, if I take, not only for the creation, we have like many other functions for all those things. So creating a 2D array from the list of list. So how can I create a 2D array from a list of list? The first one is, I'm just executing this code. Yeah. So here, some of the codes are already executed and some of the codes are yet to be executed. So here, earlier we have seen that as apart from zeros and ones, I mentioned 2 comma 3. So 2 comma 3 is a dimension where that is m comma n, where m represent the rows and n represent the column. So apart from that, we have seen a list as a also range function. So these are like a single dimensional. So if I want to create a two-dimensional array by a list of lists, so you can give like either mentioning a dimension 2 comma 3, or even the dimension is 3 comma 3 here. So you can give either by mentioning a dimension, or even you can give a list. So I mentioned like creating array from a list of list. So I just want to, as you all know, I already given in a slide also. So matrix is a collection of list of lists. So I just created a list with a 3 list. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is a each and every like 1, 2, 3 is a separate list. 4, 5 is also a separate list. So I'm just passing a 3 list as a single, as an argument for the numpy array. So this is a creating. So first we are importing a numpy as np, as you all know, and then I'm creating a list of list. So that is what. So I'm creating a single list where I'm having a multiple list also. I'm passing that particular list as a array function in array function. So np dot array function, I'm passing the list, and then I'm just creating a 2D array. So here I'm having 3 rows and 3 columns. So this is one option to create a 2D array. Either you can create a 2D array by mentioning a dimension as we see in the zeros and ones, or other one is you can create by using a list of list also. So next one is, apart from this, you should know, like, I just want to know, there are many built-in functions, but of the equal important is like what are the different arguments that can be passed in a like numpy array. So you can specify the data type. So you can specify the data type like whatever array it is, data type you are creating. So you can specify the data type that can be either a float, integer, boolean, string, or even object also. So you can specify, and there are some functions like there are some functions also required in order to pass the data type argument. We'll see. So some of the built-in function is, so I will execute again. Yeah. So first one is like we have to pass the data as an argument explicitly. So say for example, this is also list of list. So I'm just importing a packages, and then I'm creating a list with like I'm just passing a 3 list as a input, and then I'm giving a np dot array by passing a list as an argument, but and also specifically mentioning my data type should be a float, though I'm passing integer as an input. Okay, so here the all the list, that is 3 list is going is all about integers, but I specifically explicitly mentioning I need a numpy array of float type. So I just want to mention data. So here I'm mentioning a float, even if you can mention like integer also, or even string also. So print array, so you can have like all the outputs will be on the floating point, obviously the decimal point. So next one is, what if the case I want as step, that is if I want to convert array from one type to another type. So first one is we are mentioning the data type explicitly. So if I want to mention the, like if I want a specific data type, now I have to mention it explicitly, like using d type, by using a float, or like d type is equal to float, or d type is equal to string. So is it possible to convert an array from one type to another type? Yeah, we can do it in NP, and that is like is going to be a as type. So that function is called as type. So that is, as the name is, it's like we have to convert the array. So I know I'm going to execute this one. Yeah, so it is already executed, but still I change some. Okay. So array 2 is equal to So so here we have used array1. So remember array1 is first we have given list as a input, that is integer, and we have created an array1 that is a float. So this is a float, like array1 is, as of now, array1 is a float type. So now I just want to use array2. Okay, so I want to convert one type to another type. So first I want to convert this one float into an integer, as well as then I want to convert the same this one float array1. Here I'm using ARR1. So that is a float data type. So that I want to convert as a string also. So first thing is, yeah. So this one is I'm just creating an array. I'm just creating a variable ARR2 that is equal to array1, which is already in a float type. Okay, the dot as type of, that is I want to convert the float in array, that is first array, which is already in the float data type. I want to convert into an integer. So I'm just using a function called as type, and then I'm passing to which data type you want to convert. You want to convert into string, or you want to convert into an integer, to which data type you want to convert, from the float to which data type. So I want to convert into an integer data type. So I'm just giving, and then I'm just printing the array. So next one is, so you'll get, yeah. So this is a array2, and similarly I just want to check whether is it possible to convert into a string also. You can, obviously you can convert into a string also. Okay, so string is always, obviously in Python you know the string, everything will be represented as string, and also by default everything is and also represented as single quotes. So first one is array, that is converted into an integer. Earlier it was float, 0, 0.1, 3.4.5. So earlier it was float, a decimal point represented. Now we are converted into an integer, and that is represented, that is stored in a array called 2. And the next one is it's a string one. So we can use this as type function for converting a one data type to another data type. So though it is a homogeneous collection of data elements, we can easily convert a one data type to other data type by giving the function as type and all. So and also we can go for like object type also. So if you are uncertain about, so say for example, if you are unsure about what data type your array will hold. So if you are uncertain about the data type, now you can simply give object. So I'm just giving like NP array. I just want to know, like I just want to hold like one also and also A. Okay, so in that case, I don't know about the specific, whether it's going to be integer or whether it's going to be a string. So I'm just, and answer, if you are unsure about the data type, you can simply give the object. So if you give, simply give the object and directly take it, whatever value you are given, it take as it is. So I'm just giving, yeah. So I'm just giving like a 1 comma A. So far we have seen like how we are creating an array, that is we can create an array, because next topic would be going to how to investigate the numpy array. So I just want to cover it. Is there any doubt? So whatever we have seen, I just want to summarize like as, because we are, the next point is going to be like investigating a numpy array. So first one is like we have seen like what is like what are the environment to be set up, and then we have seen like how the numpy array can be created. What are the functions? We have seen like built-in functions like zeros. If I want to create an array of ones, like if I want to create an array of zeros, and then if I want to create an array, you can use like pass list as an argument, or also we can pass, you can use a range function also. So these are the things that for creating a similar. If I want to create a multi-dimensional array, you can use, that is, this is for vector, that is list of list. And if I want to create a multi-dimensional array, like a two-dimensional or three-dimensional array, you can use like specific the dimension also, so that we can give for it. And also we have seen the arguments, that is in NP array, what are the different arguments you can pass. So in NP array, we can pass like data type D type. So D type can be a float, or it can be an integer, or it can be a boolean also. So you can, once you created the array, you can mention, you can specifically mention the data type also. So once you created the array, is there option to convert from one type to another type? That is also possible. So you can use that as type function for converting a one type to another type. So we can use as type function for converting from target, that is from the source to the target. So ARR1 is the source, that is floating point, and then I just want to convert into an integer. So that should be your argument. So as type of int. So these are the thing. And then if you are uncertain about the data type, you can simply give the object. So data type object. So next one is how to, that is inspecting a numpy arrays. There are like, if I want to inspect or if I want to investigate a numpy array, so for example, the properties, whatever I have created an array, if I want to find out the properties of the particular array or the features of the particular array which I have been created earlier. So you can use some of the, that is, you can use some of the functions. So like, yeah. So here we are having, let's see this one. Yes. Okay. So here you are having some of the function, that is some of the like print ARR1 is the array, that is numpy array. So with this numpy array, if I want to investigate the particular numpy array, I can use some of the commands also. So if I want to find out the shape of the array, so this is comes under inspecting a numpy array. If I want to investigate, so say for example, this is like a, as it is a beginning, I'm just taking a very small size of the array. So for example, if you are having one particular like image pixels, so if I want to just investigate the particular pixel array, so you can use all these functions. So the higher end application is you can go for image processing and all. You can convert all the images into a pixel array, and then you can use all the convert into like numpy array, and then you can, the pixel array can be called as a numpy array, and then you can use this numpy array like investigated as some of the shape, d type, size, and all for the any of the applications I'm selling. So this is just I'm created only a 3 cross 3 matrix, that is 3 cross 3 matrix, or even you can use a spreadsheet also. So obviously rows and columns are spreadsheet. So that is one. So you can use like a image application, or you can use a spreadsheet also. So that also you're having rows and columns. So you can use this rows and considering the rows and then like fields and then columns as a values. You can use all those things. Just investigating the particular array or investigating a particular like a matrix or whatever. If it is a two-dimensional, fine. So here I'm having like printing the same. First we have created array one, so that is I think, yeah. So this is, I hope you remember, this is a float data type which we have created. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So I just create pass the list, and then I want explicitly mention I need of only float array. So I just created so decimal points, so 0 0.1, 0.2. So first I just want to check what is the shape of the array. So if it is a huge one, like if for example you are dealing with a pixel like image, so you're dealing with a full complete pixel array. So you like imagine it is a very huge one. So for that case, you can use the shape function. Here it is very simple. That's what I said. So as it is a tutorial, I'm just taken a very basic example. So you can just correlate this with the any high like applications kind of spreadsheets, or you can consider like images and all. So if I want to do some image parsing task, now you can take this and convert the image into a pixel. And then if I want to check the size of the shape of the particular array, you can use this one. So array one dot shape. So here the shape of the array is 3 cross 3. Yes, as it is a very by just looking at the array, you can simply say like a 3 cross 3. As I, it's a tutorial, so I just taken only like small values of this small size of an array. So next one, if I want to find out the data type, so say for example, I just want to know like how the elements are distributed, what type of elements that the array is holding. So what is the, it's a collection of what kind of items. So for that case, I can use array one dot d type. And then we are having array one dot size to check how many elements you are having. So that is overall shape is like a dimension, 3 cross 3 dimension, like it's like a because the rows and columns. Okay, so here like how many arrays, it's a two dimensional and having two values. That is the size of the like the dimension is 3 cross 3. And then like this one, array one dot size is how many elements you are having, and the dimension is 2. And also like a very important one is like memory size and number of bytes. So this is these two lines, this is these two attributes. That is, so array is already created and I'm using items byte. So if I want to find out, if I want to know, so the size of the item, that is, it's already a collection of items only. So I just want to know the size of the items. So I'm just giving a bytes 8, because as you all know, the data type is float, and you know like how many bytes are required. So item size, so each and every item size is 8 bytes. So that is what, and overall the memory size is 72. So it's a very simple array. So you can easily calculate by looking at the array itself. So this is just a if you want to, taken like any higher application, you can use these two. So to find out the like memory capability, that is how much memory space it's required. So you can use n bytes. So the array dot n bytes giving the memory size. So here the memory size is 72 because so each bytes requires, that is each item requires 8 bytes. So that's why the memory size is 72. So you can use this as these many features, the shape, d type, size, and the dimension, item size, and all for investigating any array. So say for investigating like whatever number array you are having, you can take these things and then you can just use this from features, and then you can just find out how your numpy arrays look like, whether what is the property, or you can say the feature of the numpy array, what is the features. So what is the shape, and then like memory size, all those things. This is like you can use for that one. So next one is, so first we have seen how to create the array. So then we have seen this one, investigating a numpy array by using some of the function, whether some of the uh, features, properties, and all. So next one is it possible to convert a numpy into list? We already seen how the list can be passed as an argument, and then how you can use that list to create a numpy array. So now is it possible to convert a numpy into a list? Because whenever you are going for any data exploration or any data analysis, so first we will take all that pandas, that is your complete pandas, and then you convert it into a numpy, and then again you want to convert it into a list or do any vectors. Say for example, I want to do any vector calculations and all, I want to convert back into a list. So is it possible? You can use the function called toList to convert numpy array into a Python. So this is a function. So first we have seen, I just covered one of, because I taken a very important functions and along with the examples. So this is how the tutorial is going to be. So this is for like, as I said earlier, data science applications, and then you have to do some vector analysis. Like if I want to use for feature vectors, all those things, I need first array and then I take a first row itself. So you can take a first row and then store it as a list. So you can, this is a function. So let me execute this one. Yeah. So here is, I'm just, so remember this is converting a numpy into a list. So that is numpy array into a list. So as usual, importing a package, and then first I'm creating a numpy array. So how I can create a numpy array in the sense, here also I'm using list only. So initially I'm taken 1, 2, 3, 4, 5 as a argument, and I'm using a list for creating array. Then I want to convert this array into again a list. So list from numpy. So from the numpy I want to create, I just convert now. So I'm using AL, that is array list. So AL represent array list, which is 1, 2, 3, 4, 5. Okay, and I'm using a toList function. So with the help of toList function, you can convert this numpy array into a list. So this is obviously helpful, like whenever you're going for like even in a deep like any other machine learning or deep learning application, if I want to do a operation in the features, the final one feature, that is feature array and all, you can convert the numpy array into a vector and then feature vectors, and then you can use it. So this can be useful in that particular scenario. So print AL. So first AL is a numpy array, and the next one is a list. So which has been converted from the array. So 1, 2, 3, 4. This is a numpy array, and this one is the elements, that is collection of elements in a single dimension, that is one row, that is called as a vectors. So this is a function that can be used for a toList. So next we will see, any doubts so far? Shall I go for question? So this is like just taken some of the functions and we have seen with the examples. I'll share this notebook also. I'll share this Colab notebook also along with my lecture materials. Okay, whatever materials I'm sharing, I'll share attach this one also. So next one is data manipulation. Say for example, if I want to work out, that is, if I want to do some analysis in the numpy array, or if I want to do some data exploration, or if I just want to do some modification, or just want to play around the data, numpy data. If I want to play around the numpy data, so what are the functions available? So first one is replacing an elements in array. So as you all know, array is a mutable, which means we can change the elements of an array. Okay, with this we can modify the elements of an array, we can change the elements of the array. And once it is created, we can have the option to change it. So that is the main property of the numpy, that is numpy list. All those things are mutable. So first one is replacing the elements in an array. So first I'm creating an array with using an arrange function. So I'm using an arrange function by creating an array. I just want to use uh, my array should be, that is numpy array. It's a single name. So I just want to create 25 to 50, which means starting from 25 and ending till 50. Okay, so I'm just passing 25 to 50. So I'm just creating an array. So then is next I want to replace the array, that is replace some of the elements in the array. I'm just giving like replace, that is a variable I'm just creating. Okay, and then np dot where, that is the function. So arrange we already know. So now we are going for a function that is called where. So in order to use, like in order to find out a specific element in a numpy array, or in order to find the specific location where, we can use this where function. So np dot where, and the argument is just I'm giving, you can directly give a value. I just used, so the context or the problem statement is I just, what the context we are going now, I just want to create the array from 25 to 50, that is n minus 1, so 25 to 49. So I'm just create, and then I want to replace all the even number as 0. Okay, so array, that is what are the elements, they are divided by 2. Okay, the elements which are divisible by 2, that is even number 0, should be replaced with a value called 0. So this is the condition where the element each and every, so we are no need to use any for loop and all. That is the advantage actually, which I said earlier also. So I'm just giving an array, you can take the whole element, that is complete object, and then divisible by 2 equal to 0. If this condition is satisfied, you can check it as a, change it as a 0, and then with where you are changing in the same AR pattern, that is the original AR. So this is, I'm just printing the final one. You can use this one also, but if you are using multiple, you can't. If I, as it is a last slide, I'm just using directly like the replace one. If you go for keep on using the simple variable now, it won't get. So we have to use obviously print statement. So as for time being, I'm just use this one, replace. So you can look at the output. So this is the output. So first one is 25, the next one is 0. As you all know, this as a witness, or you can like I say it as a proof, like a array is a mutable number. It is obviously an numpy array is a mutable, that is arrays are mutable. So you can change the value of array even after you created the value, complete an numpy array, even you can change after that also, you can change the values. So for that I can use the where function, that is how to replace the elements in the array with the help of some condition. That is what. So if I'm having some condition and I want to replace the elements which are satisfying the condition, I can use the where. So this is the snippet for snippet for replacing the elements in the array. So next one is, here earlier we have seen, we have taken the value and we have passed some condition. So instead of that, if I want to replace the value on the base of index location, so yeah, it's correct. So if I want to replace the value of array elements with the help of index. Okay, so obviously whenever it's an array, it starts from 0 to n minus 1. So here I want to replace the value at index 0, 3, 5, that is whatever comes under the 0. So here we have taken like AR only. So AR is like this one, the original one. Okay, so REP1 is the replaced one, but here I have taken the original one. So first one I use the even, that is even condition to take wherever the even number of that is elements is even, we can convert it to 0. This is first option. Next one is the same, the parent, that is AR, can be converted, can be replaced with the help of, can be replaced with some of the elements with the help of index. So I'm taking using the function called np.put function. So which is, you can directly take an element and you can directly put the particular element in the specific location. Okay, so earlier it was a where function where I just want to replace the element whichever satisfies the condition I represented over there. The next one is, if I'm giving some location, is it possible to change the element instead of going for a condition by using some index location? So we can use like a put function. So np.put function, it's like a given like np.put function array AR, and this is the index 0, 3, 5 should be replaced with 33, 55, 99. So first one is your array and then your location, and the next one is a new value. Okay, so these are the things. So first one is array 0, 3, 5, 33, 59, 99. So 0 is, and so here earlier 0 is 25, and then now it is converted into a 33. So next one is 3, that is 0, 1, 2, 3. I just want to convert into a 55 and then 99. So 33, 55, 99. So I'm just using the first one, AR only, which is array of, that is a range of 25 to 49. And the one is I convert replacing an element, and this one is I just want to use the put function. So we have seen two functions. One is where function, another one where function is for finding out like condition to, if the condition is satisfied, directly go to the particular location and just put the, or just replace the element to the new one. So these are the two like data manipulation is just playing around the data, that is just whatever data that's the numpy array is stored as holding. So what if the case in your data set, or like even if your spreadsheet, or even if your matrix, or even if some other like application, if there is any missing value in the array, so how to deal with the missing values in array? So, and that too, like, is there any built-in functions that the numpy is providing? So yes, we are having how to deal, that is we are having some uh, built-in functions to deal with the missing value. So first one is, I'll just, yeah. So first two liners, I'm just creating a numpy array. Okay, so I'm just creating a numpy array with the values. First one is 10, another one is np.n, is no value to be assigned. That is, I don't want to assign any value, just give us an empty value. That is null, that is it's like a null value, NaN, and then 20, 30, 60. Again, nothing is going to be assigned, 90, and the next one is np.inf. So here np.inf is just reserve the particular location for infinity. Okay, so I'm just having 1, 2, 3, 4, 5, 6. So I'm having 8 elements. I'm going from 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I'm having an 8 element. I just want to collect all the 8 elements. I'm reserving 2 for empty one, and the last one is for infinity. So for that, you can use np.nan. Just intentionally, I'm giving a null value, and then I want to check. So how to deal with the missing value. So I'm giving a null value nan. You can use np.nan and then np.inf, that is for infinity. So I'm reserving the last location, that is last element is going to be a infinity. So now I want to search if there is any missing value. If there is a missing value, just return a boolean array. Okay, so this, yeah. So to check, so obviously this is the output, that is print A. So the obviously the output of the print A is like you are having 10. This one is your print one, and I want to search the missing value. So if I want to search the missing value means like, and then first I'm created an array 10, empty, 20, 30, 60, again empty, 90, and infinity. So I'm having 8 values in my, that is the array A is holding 8 values. Now I want to check whether is like, is there any missing value? If there is a missing value, please return me a boolean array. So for that we need a function that is called npisnan. So if there is empty value is nan. So if this condition is satisfied, obviously it's a boolean array. So boolean array will have only 2 values. So what are the values? True and false. So if the condition is satisfied, that is going to be a true, or else it is going to be a false. So here I'm checking the condition is nan, which means if the elements in the numpy array, I just want to check element by element, that is element wise. So if the element, whichever in the numpy array is empty, then return me a boolean array. So we'll see whether it will have true or false. So if is, and also index of missing value. So where the particular means. So this is the missing value, that is this print statement. The print miss value of NP is name, that is none, is that is like, I just want to create a boolean array, and that is a missing value. That missing value is false, true, false, 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 true, false, and false. So here if you look at, like, if you the pretty of the like, if you look at the deeper one, so I'm just creating a boolean array. So obviously boolean array is true, one is true and false. And here the, according to this context, true is going to be like missing value. So in this case, the missing value is in the second location. So that's why we are having true over here. So that is what the context is referring to. So I just check whether any empty elements in the numpy array. If it's so, give me a output in a Boolean format. So here the condition is satisfied because obviously the second location is empty. Therefore, we are giving true. So we are having two empty. That's why we are having true. And look at the last one. As I said earlier, it is reserved for infinity. Okay, so it is reserved for infinity. It is not empty. It is reserved for an infinity value. It's not like a 10, 20, 30, 40. It's like it's reserved for a positive infinity. That's why that is also not considered as a null value. Okay, and also so this NaN is for like it's a boolean. Obviously, this means it's always represents the condition. So is NaN whether it is true or not, is true or false. So if NaN is true means obviously you get empty value over there. If it is empty value, true. If not, false. So where like if I want to find out the location, so if I want to do, I just want to replace later on, if like I just want to replace the particular empty value with some other value, or I just want to do some manipulation over there, or just I would just want to do some modifications over there. I just want to know the index. So for that case, obviously I'm just going to use the np.where, and then I'm getting the rest wherever you are having this yeah. So wherever you are having this empty value, just give me the location. So the location is 1 comma 5. So this is the like data manipulation, I think. Yes. So yeah, so first we have seen like empty, there's missing value in array. So I'm just I just created a new array intentionally with the missing value. So how can we create some intention like null value? I can use NaN, and then you can use this man function to check whether my array is having any empty or like null value or not. If it's so, you can also get the index by using var function. So we have seen like np num, np infinity, np is null, whether it is empty or not, and also we have used the var function to take the index. So once you found out the index, the next step is what? You have to deal with the null value. So how to deal with the null value? Obviously, you can use replacing the missing value. This is a little bit output. Yes. So once you got the index 1 comma 5, the next one is you have to check whether like you have to deal with that. You got the location, then you have to deal with it. So I just want to replace. Yeah, I'm replacing all the rest. Wherever there is an empty value, I want to replace with 100. So look at the output. So 100, 10, 100, 20, 30, 60, 100, 90, infinity. So still infinity is reserved because that is not going, there is, as it is not considered as a null value, we are not touching that. We are dealing only with the null value only. So infinity is just reserved for that high values. Like we can take for any higher end, like you can take it like a max cap, whatever in the array. Say for example, in application oriented, if I want to say, no, like if there is any vectors and I want to fix like a max cap at the end, or it's like we can take it as threshold, whatever value, we can configure this as infinity also. So whatever the modification manipulation you can do like just before like threshold or the max cap value also. So this infinity is for that case. Just correlate the basic functions with the applications also. So you can take any other feature vectors with the threshold value or like max cap value. So again, I'm checking if there is any missing row. So I just dealt with, I found out the location. So 1 comma 5. So obviously this is 0 and then 1. And the next one is fifth location. Both are replaced with 100. So next is, again, I'm checking, is there any missing out values in the numpy array? Now the condition is obviously false. So I'm just using any only. So if you are still giving this one, it's create a boolean array. If you are using till here, will create a boolean array. I'm just checking if there any. So true or false only. I'll get only. I'm not creating a boolean array. I'm just creating a boolean output only. So the boolean output is yes or no. So S means yes, it is a is there is a null value. Like no means it's there is no null value. So I'm just using this any function. So here we are using this. So earlier we are used till over here. So instead of taking all the functions one by one, I can just clump it all the way. So this is just a boolean array. So till is none as a boolean array. So we'll have like a element by element. So true or false. So take a element and compare all those things. And I use the any which yeah. So which means like obviously the like any true or false value is there any null value. So we'll get a final output like yes or no. So S means yes if that is a true. So here no such null value because obviously all the null values have been already handled. and we have replaced with the 100. Therefore, no null values, therefore the output is false. That is, the value is false. So these comes under data manipulation. So data manipulation is just finding out like is that like mutable, that is whether I can able to replace the elements. And even we can I'll tell you in a couple of minutes, we can make the arrays immutable also. So by default array is immutable. You can make it as a once you create it, you can make it as you can make any modifications in a upcoming time also. But even you have an option to make it as a immutable. We'll see. So that I will see that after a couple of minutes. So we can first, so data manipulation is just playing around the data, as I said. So we can use the replacing function, or you can use you replace with the help of condition or with the help of index, or you can have to deal with the missing values. So if you have a missing value, it's element by element manipulation. So taking each and every element and doing some operations or manipulations. So these are obviously comes under data manipulation. So here we have seen nan, infinity, is none, and then any functions and all. So next one is operations of array. So this is like a very simple operations. Like I'll just, we have seen, yeah. So we have first started with how to create an array. Then we have seen like a 1D array, 2D array in a NumPy. Then we have seen how to investigate that NumPy array. If you're already having a NumPy array, how to investigate the particular NumPy array, how to inspect the particular NumPy array, what is the shape, and then memory space, and then data, item size, all those things. Then we can go for the data manipulation. So once you've done all the inspection and all, then you can go for the actual playing around the data. So you can go for the data manipulations and all. So next one is operations on array. So here, in this operations on array, as you all know, we have I have taken a very basic very notable or most fundamental or functions only. There are a lot of functions in the operations array. I've taken only fundamental, also most important. So array operation, I'm just creating an array operation as a AROP as an array name, and I'm creating a NumPy array. So NumPy array from 1 to 20, which means starting from 1 and goes to n minus 1. So you will have 1 to 19. And then I'm just printing an array. So this one is the particular output for the first one. And I was using an operation. First one is I just want to sum up all the elements in an array. So you just want to sum up. I need a sum of all the n element, or I just want to find out the the sum of the all the elements in array. So if you want to do in that case, you can use the sum function. So next one is there are some situation where you want to do some cumulative sum. So I don't want sum of all elements. I just want the cumulative sum. So a plus b, then a plus b plus c, then a plus b plus c plus d. So in that kind of. So for that case, you can use the cumulative sum function. So here I have taken two functions. One is sum function, another one is cumulative sum function. So sum function is returns the final sum of all the elements in the array. So next one is cumulative sum. So here 1 and 1 plus 2, 3. Again 1 plus 2 plus 3 is 6. Again 6 plus 4 is 10. 10. So you will get the cumulative sum. That is I need an element, that is an array itself. I need a cumulative sum. That is cumulative sum array. Okay. So I can use this CUM, cumulative sum. The shorter form is cumulative sum of the particular array. So if you pass now, you will get the sum of all cumulative sums and the final one. So this is an array operation. And as you all know, apart from this sum, obviously this NumPy array I stated earlier, it's a numerical calculation, that is completely statistical analysis. So you have some of the functions with respect to minimum, maximum, and then standard deviation. Obviously, if you are having a data set and you want to do some statistical analysis, now you can convert the data set into NumPy array. Say for example, you can use the pandas and convert into NumPy array and use all the statistical functions which are inbuilt functions in the NumPy package, and you can use. So some of the functions are, I used minimum function. I just want to find out the minimum value, and I've taken the index of the minimum number in the array. So first one is what is the minimum value, and the next one is no, I just want to know the location where the minimum value is located. So in that case, you can use the argmin function, and also argmax is same index of the maximum function. So instead of giving a max, obviously, if it is a min and then take the smallest value, so maximum will always take that 190 will be output. So instead of that, I just want to know the location where the maximum element is residing. So you can take that argmax. It returns, obviously, it always return the index of the maximum element in that particular numpy array. So if we want to find out the variance, so if we have like a complete data set, that is spreadsheet, okay, you have some, say for example, I'm having a glucose level or some other level in data set. So you have to find out the variance and then standard deviation, how the values are distributed. So you can use this two function. One is np dot variable, whereas variance, another one is standard deviation. So yeah, it's actually quite down. So obviously, the minimum is 1 and the index is 0, and argmax is, that is 18 is not a maximum element, it's the index of the maximum element. It's the index of the maximum element, and that is 18, and then we have like variance, so standard deviations. So next one is, so these are all operations on the 1D array. So what are the different operations are available in 2D array? I'll just quickly wrap up the operations on 2D array. So, yeah. So 1D array, you can have sum and then cumulative sum, the basic form, the fundamental one, from cumulative sum and then sum. And then next you are having this statistical functions and all. Those are comes under statistical analysis. So here if I want to create, yes. So if I want to create a 2D array and I want to do the sum. So I'm just creating a list of list by passing a list as an argument. I'm creating a matrix as a list of list. So I'm passing this value, and then this is the first one is the array, and the next one is like a dot sum. So we can take a sum value, like I'm taking like this, all the sum values, okay. So a dot sum. So next one is column wise minimum value, that is np dot a minimum, whereas we can take column wise minimum value, complete column wise minimum value also. This is yeah. So this is, you can even take a row wise minimum value also, and then like by mentioning like axis is equal to 0 and axis is equal to 1 with mentioning a row or column. So here I just taken this sum and then column wise minimum value. So any doubt? Because I don't have chat. So final one is just enumerating, that is we have a couple of, again I told you earlier like how to convert the array into an immutable also. But before getting into that, there's like enumerate for numpy arrays if I want to find out the index along with the value. So the particular value of the complete 2D array, but I would just want both index as well as the value, is 0, 0. What is the value located in the 0, 0 and then 0, 1, 2, 3. So this first row and all the 4 columns. So I'm just giving an index, the complete index comma value. So I want such type of output. So I just want to investigate the array in such a manner. Now you can use np dot nd enumerate as n dimensional, which means we have to use, because obviously it's a index. So index means like we have rows and columns. So it's like a nd for this multiplication. So you can go nd enumerate and give the array as an input, that is argument. So you can have both index as well as the value. So finally I'm having like, this is all about 3 cross 3, which means like 4 cross 4. So 4 cross 4 elements, therefore the final one is 3. So this, like if you want function. So these are the operations that are available in the 2D array. So we have seen like NDI, like as like due to time constraint, I have taken only like they are like very important and then like very notable functions that can be used in any kind of statistical analysis or data exploration part also. So apart from that, there are like many functions also there, but these are like the very basic and fundamental functions that need to be known for if you are going for doing any statisticals or like data explorations and all. So next one is also like this is just like, as I said, it's an operation in a 2D array. So I'm just creating a like array 2, that is I'm creating an array np array of 1, 2, 3, 4, 5, 6, 7, 8, and then again I'm creating a number one. So this is just adding a scalar value, that's it. Okay, so if I want to add like element wise a scalar addition. So as you all know, scalar is a single value. I already explored, I already informed, like we already discussed. So scalar is a single value. So if I want to do a scalar wise addition, you can use this like I just created two arrays. Okay, each of says 3 cross 3. That is a no 3 cross 4. Okay, so and then I'm doing adding a scalar. So simply you can do array 2 dot plus 3. But we already see this is not possible in the list, even if it is a vector like a single row also you can't do it just because it's always affected in concatenation. So array. So we'll have an output. So array 2 is this one. So 1, 2, 3, 4. So we can add each element by 3. So 4 and then 5, 6, 7. So this one and then element wise subtraction also is possible by giving array 3 minus array 2. So simply giving array 3 minus array 2 you can go for element wise subtraction also. Yeah. And then division by scalar. So obviously if it is addition is possible, obviously division and multiplication are possible by using a scalar, as well as you can use element by element operation also. Like if you want to do like two matrix subtraction or matrix multiplication, you can simply do those two. That is a major advantage of the Python NumPy. So element wise multiplication. So modulus with scalar, all those things are. So this is just I just quickly wrapped with this array 2D array operations and also arithmetic operation. As I said earlier, we have arithmetic operation and broadcasting is a very important features of NumPy array. So this is the arithmetic operations that deals with this 2D NumPy array. So we can use for scalar addition, multiplication, division, as well as you can go for element wise, that is two matrix multiplication, addition, subtraction also by simply giving a single like command or line of code. So next one is, yeah. So as I said earlier, so these are about the operations, like these are very basic, like very fundamental operations that is required for when you are dealing, because as you all know, they're like even like there are a document, I have a reference slide also. So we have a complete documentation over the NumPy, complete documentation where you can see like a number of built-in functions. But I have taken only a notable functions that is required for whenever you're going for any data analysis or data exploration kind of task. So as I said earlier, NumPy array by default it is a mutable. But is there any possible to make it as a read-only NumPy array? Which means I just want to make it array as an immutable. No one wants to change the NumPy array. You can make it as a NumPy array as a read mutable by raising a flag. So this one is required. So flag dot writable means like if you are raising the flag, it's said to be a false. Then no one, which means like no one can edit that, no one can modify the element of the array. So I just yeah, it's obviously gives false because I taken this one. Anyway, I'll explain this code. This yeah. So here I'm just creating an array from 10 like 10 to 100 with the increment of 10 with the increment of 10. So and then this is a read only. I'm just creating an array name itself a read only. Then I'm making a this is till now then up till here the array is a mutable one. You can even go for like a read only of 1 equal to 20 possible. Let's see. So fine. So this internet is also again. Yeah. So read only of you can check it out. Like you can better you can take it as a task. You can take this till here. So I'm just creating an array with any kind of name, and then you can just make any modifications by giving an index. That's it. That can be possible. So if I want, after some point of time, I just want to keep my array, whichever I created, to be a constant throughout the execution or throughout the task. So in that case, you can make the array as an immutable by raising the flag. This is a very important like option, or you can say it is a very important feature which can make NumPy array as an immutable. So what is that flag in the sense like array name? The syntax is just given an array name. So which array you are going to be make it as a constant. That is the array which you are going to make it as a constant. So array name dot flag, because I just want to raise a flag to inform that this array is going to be a constant. Therefore, no more modifications for the particular array. So in that writable. So it's equal to false, which means like by default it is a true for it is you can everyone can flags dot writable is a true, which in that case only you are taking as a like you are manipulating you can manipulating the NumPy data by replacing or finding out the null value and then getting handling with the null value, all those things. We already seen all the examples. by default, all the numpy array or whatever array you are having array is a mutable one. You can do all the calculation. But after some point of time, I want to keep my array as a constant one. You can just raise a flag and set it as a false value. So after setting as a false value, if you give read only of 1 equal to 1000, it throws the error. Yeah, yes. Yeah. So assignment destination is read only because I just given only false, which means writable is false. Only read only can be possible. Therefore, after setting the false, you are doing the modification. In that case, you won't get output. That is, you can't replace the value. So we are just changing the default. With the help of this particular features, we can change the mutable array into immutable also by raising the false dot writable, which means I'm making a writable as a false. Therefore, writing option is a disabled, so you can only go for the read only option. So that's why we are getting an error, that is assignment destination is read only. So you can't change the value here. So you can't, whatever left is, you can't change the value because it's already raised as a false. So you can again have to be revert back and then you have to go for the modifications. So this is, I just want to share this particular feature because like a very interesting one. It can be applicable, useful when you're going for like a iron application, obviously. So you want to make one after setting some like manipulations or any doing some processing, you want to make that particular array to be a constant, and then you can make it as an immutable, and then I can do all the calculations by taking a reference of it also, so that it won't get affected. Whatever calculations you are doing, that particular array will not get affected. And then the last one is like, as I said earlier, we are having two, that is arithmetic calculations and broadcasting. So that is numpy array supports arithmetic operations, as you already witnessed the arithmetic operation between two arrays with different number of dimension. Okay, that is what broadcasting is. So with the help of broadcasting, you can perform the arithmetic operation between two arrays with a different number of dimension. So dimension is obviously size of an array, rows and columns. So if we are having different numbers, we'll see. So I'll first, because I'll first check this one once that it's executed. Yeah. So here array 2 is equal to, I'm just creating an array with 3 cross 4 elements. Okay, so either 3 cross 4 is the shape. So array 2 dot shape is a 3 cross 4. Then I just want to, I again created a one array called that is array 4, and this is like a 1 cross 4. Okay, so that is 1 row and 4 columns. That's where we're having a 4. So array dot shape. So now if I want to add, so as per this compatibility, that is shape compatibility, though there are two different functions, that is dimension. So in that case, like it's just here we are passing a single row. Okay, so this single row we'll see. So if I want to add this array 2 dot, that is array both 3 cross 4 plus the 4, there is 1 cross 4 elements. So what will happen? Obviously, it won't throw any error because that is the functionality or beauty of the numpy array. That feature is called broadcasting. So what we will do now? So even though if it is a different number of dimension, so 3 cross 4, I'm having 3 rows and 4 columns, but I'm passing 1 row with 4 columns. So what I will take now? So remaining 2 rows, I can take this reflection. Okay, so this array 4 will be reflected to the remaining 2 rows also. So that's why it is like, so look at this one. So 1, 2, 3, 4 plus 4, 5, 6, 7. Again 5, 6, 7, 8 plus 4, 5, 6, 7. Yeah, that's why we are having 9, 11, 13, 15. So that is the beauty of the broadcasting feature. So broadcasting feature is, though it's a different dimension, we can take that particular array and make it as a reflection. Okay, and make it as a reflection, and then we can use it as a addition, as whatever arithmetic operations we are having, we can take it as a reflection. So this 4, 5, 6, 7 will get added with these two rows also, because internally the Python, whenever you are giving that, it checks for the element, that is okay, it's compatible with the elements. At least we can, obviously if you give 3 now, that is 1 cross 3, it won't fit it because I need at least 4 elements in a single row. If this condition is satisfied, then I can easily reflect the particular element, can be reflected into other 2 rows also. That is called broadcasting, and then I can perform the arithmetic operations. So that is what the output is. Yeah. So if you change now, that this one like will not like, at least the base condition is like you need at least 4 elements of first row, or even you can give that at least 3 rows. So that it can be reflected to that all the remaining rows or dimensions and all. So that is the main point. that is NumPy array broadcasting. So that's all about there is the tutorial is all about like I just taken like as I said earlier, I just want to repeat the same point that the NumPy is a package, a kind of baggage where you have to take all the steps under. So here the steps is I have to covered only a minimalist steps only. I've taken only built-in functions, very basics built-in function, and also most fundamental or like commonly used built-in functions whenever you're going for a NumPy package, that is using a NumPy or statistical analysis. Obviously, whenever you're going for data exploration, you need a statistical analysis also. So I just covered, I taken this covered in that manner only. So first we started with this. I just quickly wrap up with that. What are the we have seen? And that first we have taken the creating array. We have seen both 1D array as well as the 2D array. Then once you created the array, we have seen this one, some of the common functions used in NumPy. And then we have seen the arguments. Okay, so what are the arguments can be passed in the array function, that is np.array function, dtype. So dtype is a very important because if I want to specify, if I want to make one data type specifically, I can use this dtype functions also. So next we have seen this inspecting a NumPy. Once you got the NumPy array, and if I want to do some investigation, I can use all this features. Then you can get that conversion from NumPy to list, then data manipulation, handling with that is playing on the data as yes. So we can take element by element, and you can do like whatever steps you want with all the data, and then moving values, and then we can go for this 1D array operation, 2D array operation. And the very important thing is how to convert the mutable array into immutable, and also very important is broadcasting. So how that the single row can be reflected or single column can be reflected to do the arithmetic operations. So these are the things we have seen. And
participants, please unmute yourself, and if you got any queries, please ask the resource person now.
participants, any queries? So this is just I have taken like covering up what are the uses of NumPy. So where we can use this particular like this like most efficient package, efficient data structure. Yes. Hello. So these are some of the NumPy documentation which I referred. So I referred some official documentations, and then like SciPy or like this one, like, and also I have taken some Python examples link also. These are the references I have taken. You can also verify. I've taken this all those things. So